Hello, geometry students. Welcome back. This is the last and final video for our Unit 3 study guide. The question reads, how can we identify similar parallelograms and triangles? What characteristics do they share? Well, this question is not so much of a problem. It's more about understanding how we can identify similar triangles and similar parallelograms. So, first of all, I'm going to draw a line down the middle. Whoops, what happens to my paper? Okay. I'm going to draw a line down the middle. That way, I can have a side-by-side comparison of what makes triangles similar versus what makes parallelograms similar. So first of all, the first thing that I know, or the first thing that we learned, was that two sides of a triangle have to be parallel, right? So like for example, if I have a point here and another point here, and I connect them, pretend that these are straight lines, that means that this line right here, if it's parallel to this bottom line here, that means that this small triangle is similar to this giant triangle, right? That was the first way that we were able to identify similar triangles. The second way that we were able to identify similar triangles was through having at least if they have at least two congruent angles. Ooh, that word congruent. We haven't used that word congruent in a while. What does it mean to have two congruent angles? So that means if this angle here is congruent to this angle here, but not only that, that this angle here has to be congruent to this angle here. If I have two pairs of congruent angles within similar triangles, then that means they are similar, right? And the last and final way that which we learned to identify similar triangles is that if there is a scale factor, if there is a scale factor, if there's a scale factor from one triangle to the other. Okay. So those were the three ways that we were able to identify if triangles are similar or not similar, right? So if they didn't meet any of these three criteria that I have right here, or any of these three requirements, then they would not be similar. But if they at least had one of them, then they would be similar. Something to worth mention is that the scale factor, it has to be the same for all three sides. So for example, if I want to take the scale factor from this side, well, this side has to have the same scale factor that this side has, then it has to have the same scale factor that this side has. They cannot have different scale factors. If they do, then they are not similar. Okay? So now, for parallelograms, let's pretend I have another parallelogram right here. Right, but I'll make this one a little bit smaller, so that way we can say that they are similar, right? So first of all, they both have to have two sets of parallel lines. Both have to, they both have to have two sets of parallel lines. Well, let's double check. This blue parallelogram has one set of parallel lines, right? Because this line is parallel to this line. If you're not following the cursor, follow the mouse, right? So that way you can see which lines are parallel. So I'm talking about this line here and this line here. Those lines are parallel. Then this line is also parallel to this one. So that means this blue rhombus or parallelogram does indeed have two sets of parallel lines. So that means, okay, this is a parallelogram. Okay. Another thing, does this parallelogram have two sets of parallel lines? Well, yes, it does. This line is parallel to this line, and this line is parallel to this line. So that means because they both have two sets of parallel lines, they are considered to be similar, okay? The next rule that applies to parallelograms that is similar to triangles is that if there is a common scale factor, whoops, I gotta move this away from here. Give me 1 second. If there is a common scale factor from one parallelogram to the other. Whoops, I can't even spell tonight. Other. So that means that, let's say that the scale factor to get from this triangle, this parallelogram, sorry, to this parallelogram is, I don't know, I'm just making up random numbers. It's definitely not true. Let's say the scale factor is 1/2, then that would mean that they are similar, right? Because everything was reduced by a factor of 1/2. The next thing that you might see here is that the corresponding angles have to be congruent. So corresponding angles have to be congruent. Okay, so what does that mean? That means that this angle here is congruent to this angle. But if I'm trying to prove that two parallelograms are congruent, that means that this angle here has to also be congruent to this angle here. So that means all four of these angles are congruent. If that is true, they are also considered similar. But wait, is there another pair of corresponding angles? Yeah, there are, or there is. These angles here, right? These angles are corresponding, so that means these angles are also corresponding. If those angles are also corresponding, if those angles are also congruent, then that means we have a similar parallelogram, okay? So make sure you have these similarities for both. That way you know how you can find similar parallelograms or similar triangles if you're asked how to identify them, right? All right, so that was it for this video. We are done with the semester. We are done with the Unit 3 study guide. All we have to do is take the final, which I'm pretty sure we're gonna pass. So that is it for me. I will see you in the next set of videos. Peace.